Sructure. And our esteemed speaker today is Mr. Esteban Amirante. He is working in CM Basi Limited, and he has a degree in mechanical engineering and a master's in business administration, enabling a successful career in developing new businesses. So, as an international business development manager at CM Basi Limited, he fosters a double-digit annual growth through global expansion of the UK firm's industry-leading offerings and solutions. Leveraging his technical expertise and commercial acumen, he builds international partnerships and spearheads the development of new products tailored to customer priorities. His leadership on defense projects worldwide showcases Basi's British technology innovation, working in many programs. So I welcome Engineer Esteban Emerente to introduce the subject and present his presentation on this subject. So welcome, Mr. Esteban Emerente.
Well, thank you very much for this invitation. It's an honor for me to be here with you today. And let me share the screen. Okay. So can you see the screen, right?
Yes, we can see the screen.
Okay, well, today I will talk about implementation of a digital twin for an offshore structure. Let me clarify that this digital twin is for cathodic protection systems only. So we are not covering other type of digital twins, but it's a demand from the industry because they want to manage their assets more efficiently. And obviously this is a tool, a service we provide that will help in managing assets that way. So just as a brief introduction of BC, we started in the 1980s, so we celebrated 40 years within the market this year. Our head offices are in Southampton in the UK, and we have another office in Boston in the USA. What we do, we develop technology for modeling and simulation, cathodic protection systems, atmospheric corrosion and fracture mechanics. And we are focused on durability and structural integrity solutions for the industry. And we can offer modeling services as well, modeling and simulation services. And obviously we work with customers all around the world. An introduction of our technology is a 3D boundary element solver. So it's not the finite elements. That numerical system was developed by BC 40 years ago. And just to mention that all of our developments are in-house. So we are not sharing our code with third companies. Everything is in-house and developed by our people in Southampton. This boundary element system has many benefits because one of the big benefits is use less resources than finite elements and can be run in a normal laptop that perhaps you are currently using for this webinar. And it's a very accurate system as well. And this is our numerical approach. This is just to say that we are not using handbook solutions or Excel spreadsheets. We are solving electrochemical formulas. Our integration domain is the electrolyte. And obviously our boundary conditions are polarization curves or polarization data. So let's start talking about how to implement a digital twin for an offshore structure. So first, we are in the digital era. We are creating a lot of data. Your telephones, your mobiles now are sending information to Google, to Amazon, to everywhere to prepare, specific advertisement based on your behavior. Well, this is the same. We are creating a lot of data, and then we need to manage that data. And let's say in the past, for instance, rubbish was taken into a lorry to a landfill. Today, rubbish has a lot of value because we can recycle many things from there: paper, wood, metals, plastic, and we can even generate energy from rubbish. So it has a value. And corrosion data is the same. We used to do surveys, and that's all. Well, we develop technology and we develop a tool that we are using that survey data to add value to our digital twins. Okay, so the problems we detected, because we started 10 years ago developing this service, this tool. First is data from inspection surveys are contained in different formats: PDF, Excel spreadsheets, Word, manual notes, pictures, videos, etc. Then the data collection is not consistent through time. So today I am coming to this point to take a measurement. I am naming point 1. Next year, I am coming to the same point. Another company is coming to the same point and is naming point A. And in the third year, a third company is coming and is naming point Z. So ZA1 is the same point, but sometimes it's not easy. Mainly when we are dealing with, for instance, with jackets that they have 1,500 anodes or 3,000 anodes. Well, it's not easy to understand those locations. And then measurements are scarce because there is a budget limitation for a jacket. How many measurements we will do for a survey? 10,000, 1,000, 100? Well, depends on the budget. So, and obviously there is a budget limitation, and sometimes those measurements are scarce. And then trends in the data are difficult to identify because a survey, if you're familiar with that, is thousands of documents that they have to be digested and prepare reports, trends, etc., etc. So with a tool to organize that info and to digest that info, it could lead to poor information management, significant hidden costs, and obviously if you need to stop a jacket or your production, it will cost millions of dollars per day. So this is how a survey looks like. Thousands of documents that has to be digested, prepare reports, trends, etc., etc. And then there is another problem. Sometimes a person in that company is trained to do that, then is leaving the company, and someone else has to be trained, understand the way to do that, understand the way to digest all that info, etc., etc. So that's why companies are asking us to provide this as a service. So we are in control of the information, we're in control of those in digesting all that info, etc., etc. So let's implement a digital twin. Okay, so the first step is a 3D digitalization. Basically, we take the structure from the design and we create a CAD file where we add the survey points and the visual inspection points. So the red points and the green points are the survey points. So a diver or a vessel is coming here taking a measurement, and the black dots are visual inspection points. So basically, the digitalization is just that, is taking the design and convert that into a CAD file. So many companies are selling that as a digital twin. Well, for BC, for us, this is not a digital twin. This is an ordinary digitalization of your asset, something that even you can do it. Okay, then obviously we can see the entire asset, zoom in, zoom in, zoom in, double click in this survey point, and a window will pop up. And we will see all the info stored for the last 10 surveys, perhaps 5 surveys, perhaps. So all the info can be stored in every single point. So we can read that info. That point will have a name. So no one can come here and say this is point A, Z, or 1. This point has a name. And well, all the info will be stored for every single point of the survey. Then we can store pictures, we can store videos. For instance, it's much better to have a video like this instead a document saying, well, everything is okay, or there are some damages in the structure. this is much better because the document needs our imagination, to understand the state of the structure. But by having that, it's more friendly. And the system will start to create some trends. So we can see what's going on in 2010, 12, 14, 16, 18. So how those potentials are moving. So we don't need to create any Excel. We don't need to create anything. We need just to load the info into the model, into the system, and the system will create that information. Obviously, we are saving a lot of time because, creating that, it could take a lot of time. And this is the way we provide the info for the digitalization to companies. So files that they need minimum computer expertise to view that. They don't need to buy any license because those are license free. And they can zoom in, zoom out, they can double click, etc., etc. We are sharing this information with integrity departments, maintenance department, and finance department, and let's see why. But for the moment, this is the 3D digitalization, okay? So we are in step 1. So let's go to step 2, which is the digital twin. What is a digital twin? A digital twin, it's a tool that integrates survey data with a simulation model. So now we have 2 different things: survey data, inspection data, and a simulation model. Why we are using survey data? To calibrate the model and understand and even see the actual performance of my CP system. If I have a 15-year-old jacket pipeline or whatever, and I need to understand how the CP system is performing. So it's not easy. So we are doing a survey, but with the survey alone is not enough to say, okay, everything is working well, all the regions are protected or whatever. Then we can use the digital twin to predict the future performance of the CP system, which is very interesting because we can see problems in advance and we can mitigate those problems. We can detect discrepancies, and then we will see what is a discrepancy. And then we can use the digital twin to run different scenarios. For instance, if I have a structure, let's say a jacket, and they are adding a pipeline next to my jacket, obviously it will be an impact from an interference between the 2 different CP systems. So we need to mitigate that, and we run different scenarios to see which solution is the optimal solution to that scenario. Or if we want to extend the life of a jacket, so when the retrofit will be into action in 5 years, in 3 years, in 2 years, well, we can run those scenarios to see which time is the best time to start with the retrofitting. And obviously we can run many other different scenarios as well, but based on the actual performance of the CP system, which is very important. So let's see how this is working. So yesterday I received survey data, inspection of measurements. Today we feed the model, and when we solve the model, which is the simulation, that's why we call modeling and simulation. So we create a model, we feed the model with survey data, and today we have this picture, the picture on the left. So this is the actual performance of the CP system based on survey data I received yesterday. So it's a very accurate picture of the CP system, okay, where everyone can see if all the regions are well protected or are within the expected range, etc., etc. We are sending this information to maintenance, integrity, and finance department. And then obviously we need to provide a prediction, because companies, they need to prepare budgets for the next year or for the next 3 years. So does the company needs to allocate the budget for a maintenance for that jacket? Well, it depends on the results of the prediction. So let's say this is the prediction in 2 years' time. Are all the regions well protected or within the expected range? If yes, well, there is no budget to allocate for a maintenance because everything is working fine. If there is any problem in any locations, well, you have 2 years to start preparing a mitigation plan or whatever you need to do with the jacket. But you need that. You know that with 2 years in advance, which is, to be honest, it's too much time to prepare everything. So what are we doing with survey data? Let's see how we verify a design. When a structure is new, we can verify a design because we can run a time-stepping process with our technology, and we can verify if a design will last 30 years, 25 years, 35 years. So this is our prediction. And our prediction, obviously, is a bit conservative because we are using standard because we don't have any survey data to predict the performance. But then, obviously, the reality is different because coatings are working better than what the standard says. There is calcareous deposit that is helping with the CP system, is helping the CP system, and there are other parameters that makes that the system is working better than expected. And obviously there is a gap. So what are we doing with survey data? Basically, we are closing that gap because we are using that survey data to calibrate our model, okay? So yesterday we received survey data, we feed our model, we calibrate the model, and we run the simulation. So this star here is this picture here. It's a very accurate because it's based on survey data that we received yesterday. And then another star here in 2 years' time another star will be here, and that star here, it will be this prediction is based on a calibrated model based on real data. So those two pictures are a very good picture of the actual performance and the future performance of my CP system, okay? So I am talking about calibration, and I am saying, well, just with a survey, with survey data is not enough to say my CP system is working properly. And let's see why. For instance, I have a structure. I am taking a measurement here in year zero, minus 1018. It's okay. Year 5, minus 941. In year 20, minus 872. All those potentials are okay. So can I say my structure is protected? Obviously not, because survey data will be used to calibrate the model, but obviously we need to create a model of the structure. If I see the entire structure, the model of this structure, I will see something like this. So the potentials here are okay, but then in other locations are not okay. So that's why we need to, obviously this is a very simple model, but that's why we need to model and simulate the entire structure, because we can detect, for instance, redundant anodes. We were working in a project of 3,000 anodes. We finished using 2,800. We saved 200 anodes, which is too much money because they were redundant anodes. In other projects, perhaps we need to add some anodes because it's not reaching 30 years. But obviously, this will be see with the simulation. So if we can see this, then we will have the entire picture of the CP system. Because in the moment we calibrate the model, we are adding the context to the measurement. Because a potential, a measurement here, a potential here, it will give me not only the potential, it will give me the entire context of that measurement, because that potential responds to a polarization curve. So what we are doing in this case, we are doing a reverse engineering. We developed this from a potential to recreate the polarization curve. So sometimes we have the polarization curve and we are taking some potential from there. In this case, we are doing that reverse engineering. We have that potential and we recreate the curve, which is very important in this case because that curve represents the reality in terms of pH, oxygen, temperature, seawater current, etc. All the parameters included in that scenario, they will be included in the polarization data. So the digital twin, as I said, is working. So we are integrating inspection measurements or survey data with a simulation model. So we have two different things, and then we compare that. So let's see how it's working. So for instance, if we have an FPSO, those green red points are survey points. So a diver came here to take a measurement, okay? We feed our model with that measurement and we run a simulation. So with few measurements, we can extrapolate the simulation to the entire asset. So we don't need 10,000 measurements. Perhaps with few measurements, we can extrapolate the simulation. Once we have the simulation, we compare. Let's say this green point, the measurement says minus 800 millivolts, and the simulation says in this region should be minus 800 millivolts. Everything is in line. Okay. Perhaps here is minus 800 and the simulation says minus 810. Well, there is no a big gap. Everything is in line. Here, the simulation says minus 800 and the measurement says minus 850 or 700, whatever. Well, there is a gap here. So this is a discrepancy. It's a gap between the simulation and the survey. We are detecting that with the digital twin. So in the next maintenance plan, not in the next survey plan, in the next maintenance plans, you don't need to review the entire asset. What you need to review is just those locations with problems. There is an anode disconnection or an electrical disconnection. There is a damage on the coating because, you know, a ship hit it there. Hello? So, yeah. So those are locations that need to be reviewed in the next maintenance plan. But obviously, you don't need to go everywhere. You have the locations and, well, there are locations that needs to be reviewed in the next maintenance plan. So that's why I said we are adding value to inspection data, like the rubbish. So the rubbish has value. Well, the inspection data has value as well. Because when you see corrosion is late, there are many corrosion problems all around the world with structures, with offshore structures, even if they have a cathodic protection systems. And one of the explanation is that survey data is not enough to identify problems or even to identify problems in the future. So as I said, a review of inspection data alone is unlikely to highlight an anomaly. That's why we need to identify those discrepancies. And that discrepancies, they could be now, or perhaps we can identify those discrepancies in the future. So this is a clear example that the discrepancy in the future. So perhaps that is the picture in 2 years' time after running the actual performance of the CP system. And we detect, look, those three anodes, they will be depleted. So obviously then the company can decide what to do. Perhaps we can run a scenario without those 3 anodes to see if everything is protected or well protected. If not, well, they need to prepare a mitigation plan, prepare, anode replacement, whatever. But they have that info with 2 years in advance, or perhaps we detect it now. So obviously, if the company decision is, well, we will change in 1 year time, well, we can run that scenario and see how much corrosion is accumulated or how the potential will be distributed during that year to see if that is safe or not, if that is a critical part of the structure or not. So the digital twin can be used to run those scenarios, as I said before, and as I'm saying always, based on real data, based on a very good and accurate picture of the actual performance of the CP system. So as I said, different scenarios can be simulated to investigate their potential impact on the integrity of the asset. So the digital twin can be run to see the future performance, to assess the addition of a new structure, could be yours or could be from another company. Obviously, that interference could be assessed, and then obviously a mitigation plan can be assessed also to mitigate that problem. Retrofits, or if you need to change a part of the structure, well, we can add that we can replace that part into the model, run a simulation. Whatever you need, it can be done with the digital twin, okay? And obviously knowing when and where the structure will start to lose protection is particularly valuable, because if we need to extend the life of a structure, obviously it's very important to understand when the structure will start to lose protection, because what we don't want is to lose those calcareous deposits that is helping the CP system to protect the structure, okay? So the same for hulls. For instance, we can see the distribution of those protection potentially 2018, 25, 27. And I remember to protect the hull in 2018, they will need 20 amperes. 2025, 200, and 2027, 300. So my question, or the question here is the rectifier powerful enough to protect the hull in 2027? If it's okay, well, nothing to do. If it's not powerful enough, perhaps in 2025, that hull needs to be sent for a maintenance because it will start losing protection. But they know this in 2018, so obviously they have enough time to prepare a maintenance plan, look for contractors, prepare a tender, allocate a budget, etc., etc. And the same, we are working in some wind farms projects, because obviously a wind farm sometimes is composed of 100, 400 monopiles, and they have to do surveys. But a survey to 400 monopiles is very expensive. So they ask us to help them in reduce that cost. So as I said before, because we can extrapolate the results to the entire asset by having few measurements, so what we are doing is we are taking the most representative monopiles, we are implementing a digital twin, and then we are extrapolating the results to the entire asset. And by doing that, we are saving a lot of time, money, resources, and we are helping companies in managing those assets more efficiently than in the past. Okay, so well, I am finishing my presentation as a summary. Digital twins obviously provides any member of the integrity department, maintenance, and even finance access to all that relevant information to make decisions, and obviously reduce costs and unscheduled downtimes. And then a picture is worth 1,000 words, because when we see, that picture of the actual performance, the future performance, obviously is more friendly than have thousands of documents in a desk and try to understand if the CP system is protecting the structure properly or not. Okay, so well, I finished my presentation. So if you want, we can start with question and answers.
Thank you, Stephen. We have few questions. First is how to deal with the information updates for the model.
How to deal with the information?
Yeah, updates for the model. If you have any update on the model, how we deal with that?
Okay, so what we are doing is we are using survey data to calibrate the model. Then if in 2 years' time there is another survey data, we are recalibrating the model based on that new data. To obviously, we need to take control of the variation of the polarization curves. So the new data will provide us more information to recalibrate the model and keep having an accurate picture of the actual and future performance of the CP system. I don't know if that was the question.
Yeah, no, it's all right.
Okay.
So if anyone have question, may please pop up in the Q&A session. I have one question. So how do we ensure that the accuracy and reliability of this real-time data, what we are feeding through digital model?
Yeah, obviously we are updating the model as soon as we have survey data available. And survey data is not data that is coming every day. Depending on the company, depending on the structure, they are doing a survey data every 6 months, every 1 year, every 2 years. So as soon as there is that data available, we recalibrate the model, we feed, we recalibrate, and then we run the simulation. So we don't need to do a simulation a day or every 5 minutes, because obviously the results will be the same, because we are not changing anything in the model. Okay, so regarding the other question, this is a service we provide. So what we need is only, obviously, to create the model, we will need the geometry, some parameters, but once we create the model, what we need only is survey data. Once we receive that, we are doing all the job in our offices, and then we provide customers with the results.
Another question we have is, have you developed similar models for onshore buried pipelines?
Yeah, we can even implement digital twin for onshore structures as well. So there is no problem that, obviously this presentation was for an offshore structure, but we can do the same for onshore structures.
Another one we have is, do we have any possibility to develop a digital twin for the asset without having any baseline or survey data?
No, because we need that survey data to calibrate the model. Without that, we can use the prediction we did when we verify the structure, but obviously it will be a non-accurate. We can do it, but the results won't be as accurate as we want.
And is there any available softwares to create the digital twin? Like if we can integrate the designing or modeling of this with some other software?
We don't know other companies offering a software to do that. In fact, I've been invited to Oslo, to China, to everywhere to speak about this technology, because apparently there are no other providers of this type of digital twin for cathodic protection systems. We are not selling a software for that. We are selling a service, because first, if survey data happen every 2 years, means that you need to use that software every 2 years.
Every 2 years.
So who will invest in a software that will be used, every 2 years?
Every 2 years,
no one. Therefore, we are offering a service with digital twin, and then it's not easy.
Yeah. So this one last question: what are the factors affecting the data for simulation?
What are the, sorry, what are
What are
the,
what are the factors that are affecting the data for simulation?
well, obviously there are many parameters that affect the data. As I said, for instance, the seawater current, the temperature, the coating breakdown factor, the pH, the oxygen, etc., etc. But obviously, we don't need all of those parameters because all of those parameters are included in the polarization data. As soon as we take a good polarization measurement, that measurement includes all of those parameters, and we can recreate the polarization curve based on that measurement. And obviously, we are adding the context of that measurement. And the context means all of those parameters. So that's why survey data for us is very important. It's not rubbish for us. It has a lot of value because we can extract many info from that data.
As we conclude, I would like to thank Esteban for this insightful presentation. I personally believe that this has immense potential in improving the structural monitoring and predictive maintenance and overall efficacy of the structure, both ensuring safety and sustainability. So before we conclude, I would just like to share about the membership of
Okay,
Institute of
so I will
Corrosion.
stop sharing here.
So currently we are offering few grades of membership. So the student membership is of course free. Then we have affiliate membership, professional membership, and fellow membership, depending upon the experiences. In addition, you can, if you want to go into details, you can look at this link. You can find all the details about the membership details. But also have sustaining company membership, corporate membership, and the branch sponsorship, which is for the local branches we are having, like in India branch or any branches in UK. So if any one of you are interested, you can please apply online, and if you have any queries, you can write it to me on arpit.go@thapa.eu. But I would encourage our joinees and our attendees to join the membership. Student membership is free, and of course, so I would encourage everyone to please join and be part of ICOR India branch. Thank you. If you, yeah, so Jayaprakash, if you can just conclude.
Yeah, thank you, Dr. Arpit. So I thank all the participants and our panelists, including the presenter for the today, Mr. Emirenti, that he has given a very wonderful, knowledgeable, and of course, with a lot of, the new ideas that have come up with his presentation, that the future of the assets integrity the cathodic protection monitoring and the important aspects of how do you predict that, the cathodic protection status. So this is very interesting, and such types of, the innovative ideas are sure to, revolutionize the cathodic protection system and the monitoring. So I thank you once all, and of course I would like to invite all the people to become a member of Institute of Corrosion and support ICOR India branch in our future. We will be organizing future webinars in the corrosion prevention, and we request all of you to support its the ICOR India branch. Thank you for all. Thanks.
Thank you very much, and have a nice day.
You too,
And
Stephen.
same to you.
Thank you everyone for joining.